In this class, we now explore infrared reflectography. IRR. Infrared reflectography is another imaging method that can be useful for the examination of our palimpsest. We have our palimpsest and we have the visible image and we have the infrared image. We just already discussed it on the technical photography lesson. Then over here we have the IR plus libero. This is the image that is done with a standard camera, digital camera modified for technical photography, but using the IR plus filter. That is a filter that can see the furthest part of the infrared spectrum that a digital camera can see, can detect. So we are talking about 1050 and 1100 nanometer. Then over here we have the IRR, so the focus, the topic of this lesson. Infrared reflectography is the imaging method that is the focus of this lesson, and indeed it allows to get a very nice imaging of the palimpsest, where we can actually remove totally the iron gall ink. So it's really useful for this specific application. A bit review of what we mean with infrared reflectography. This one is the electromagnetic spectrum that we analyze with our imaging methods. So we have here the part that we can do with technical photography. So we start with the UV, then we have here the visible, and then we have here the near infrared until 1100, that is the area that we can see with our modified digital camera, like the Nikon D850 or whatever camera. Then from 1100 to basically 1700, we have this other further infrared spectral range that we can see, we can detect using specific scientific cameras. So those are cameras that are not consumer, so the cost is much more, so they are just used for scientific or industrial applications. And the most common, the most approachable in terms also of cost, it's called the InGaAs camera. So it's over here. InGaAs is an acronym. Basically, this acronym is indicating the chemical elements that are used to dope the silicon wafer to basically to get this kind of sensor. So InGaAs stands for indium, gallium and arsenic. Generally, these kind of cameras are used in art examination because the pigments in general, most of them, they become more transparent when we move into this furthest infrared. So over here we have this drawing of a painting. So this one will be the wood support, this will be the white preparation, this will be the an underdrawing, and then this one represents this line, the paint, and this one is the varnish. So the idea is that compared to the standard infrared reflectography, so this further infrared can go better through the pigments. That's the idea. So we can tell better an underdrawing. So this will be the main application of this technique for art examination. Here we have a nice example. This one is a visible image, infrared, so this one is done with a standard digital camera for technical photography. In this case we see that some pigments becomes transparent, we start to see some of the design, of the drawing of the figures, but pigments like this one, the green, is still very opaque. When we move into the infrared reflectography, we see that the drawing is now totally visible and we can appreciate all of it. Let's focus now on our topic, the iron gall ink. So over here we have a reflectance spectrum of the iron gall ink over a cardboard, as it is in our pigments checker. So this spectrum was collected with a reflectance spectrometer, an INGAS reflectance spectrometer. So basically it's the same kind of sensor of the infrared reflectography camera, but is a spectrometer. So basically this spectrometer can cover the same spectral range. So we are starting from basically 1000 over here, and then we move until 1700 over here. When we move from the 1000 nanometer, that is basically the range until here, basically when we use libero filter, where the digital camera can see. Okay, so with a digital camera modified, we can go up to 1100 nanometers, so this is a bluish region, in particular when we use the infrared plus filter libero. When we use an INGAS camera, we can go up to basically 1700, and in particular you see here there is the curves goes up until here. What this curve tell is that basically this one is the reflectance. The reflectance, basically, since iron gall ink is painted over white cardboard, in this case basically reflectance means transmittance, how transparent the ink has become. So what we see is that going further into the infrared, so up to this region, so here we are at about 1400, we have the point where this ink become the most transparent. And this explains why when we do infrared reflectography on our palimpsest, the A and the B that are painted with iron gall ink, they become totally transparent, better than what we can do with the infrared plus filter libero. So basically using a standard digital camera. We have the visible image, the infrared, we're using the standard infrared filter that we found in the Robertina filter set. Then we have the infrared plus, so we are using the farthest part of the infrared spectrum using this specialized filter, so iron gall ink is still more transparent, yet more transparent. Then when we do infrared reflectography, over here we see that the ink has totally disappeared. In this table I collected basically some info to summarize the specifics and compare IRR with basically the IR plus filter libero. So basically where we use a standard digital camera and when we use the infrared reflectography camera. Iron gall ink transparency is definitely better when we do infrared reflectography. So we saw the example over here, we saw the reason why it happens from the reflectance graph. So definitely if we are focusing on getting the better transparency, better use an infrared reflectography camera. Go up to 1400 nanometer. Then we have resolution. So we see here in the table resolution is better with the digital camera for technical photography. This photo over here is a comparison of the dimension of a technical photography photo. So I'm using the Nikon D850. So I see basically here I took a photo of the palimpsest from the top. Okay, so this image basically has a dimension of 8000 pixels, so it's up here. So the dimension 8000 pixels by 5000 pixels. On the other hand, over here, this one in gray, in black and white, gray tones, is the image of the palimpsest, but done with the INGAS camera. So these kind of cameras, they have a sensor of the dimension of 320 by 256 pixels. So this is the actual comparison. So you can tell that the difference is very important. So even if with the InGaAs camera we have a better transparency, though the resolution is very low, so we need to take a lot of images to put them together and to do what's called mosaicing. I mean, depending on your application, you can do that if you actually need it to have this transparency, but already what I'm saying is that with the technical photography, since you have so much more resolution with just one shot, it makes sense at least to explore this technique first. And now we explore the other feature, equipment cost. Of course, the cost of the technical photography camera that you also use for technical photography, all the UV and so on, is much less than the infrared reflectography camera. Okay, so definitely an InGaAs camera will be a further investment that you can consider when you really need it. Okay, because of course the cost of a simple camera, they will go from 50,000 euro, dollars basically. Experiment time. This is the InGaAs camera, so you see it's pretty small, just this one. This one is our panoramic head Valeria that is used in order to do the panoramic acquisition of an image and then do the stitching process. The InGaAs camera is connected to the computer, so we are going to see its image over here. This one up here is the acquisition software of this InGaAs camera. Right now, you see the image is totally black because we are just using in this studio LEDs source lighting. So basically there is no far infrared. So we need to turn on from my phone the halogen lamps. So you see now the halogen lamps are on and the image on my back it's on. So we see the palimpsest. You see I'm moving this one. So we are live. And so this is, we see the beta and the gamma. And we can better make the iron gall ink more transparent if we put on the InGaAs camera a filter that can filter out the near infrared, and so we just see the furthest infrared that we can see with this camera. So for example, there are filters, generally we use a filter that filter out everything below 1500 nanometer. So we just see 1500, 1600, 1700. This is the image, and then from the software we can also move this panoramic head if we want to do an acquisition of all of it. So for example, go here in the computer. So this one over here is the software to control the panoramic head. So basically I can go here on the computer and I can move the head, for example, up and down, so to match, so this direction and this direction over here. So and basically then from here we can set up the panoramic acquisition. If you are interested to this panoramic method for infrared reflectography, on our website we have an online free course. So as usual you can go here in the training programs, online course, and looking for panoramic infrared reflectography over here. So there is this course with these videos. So this is the equipment, it's called Valeria, and then basically from here you will have an introduction on how to use this equipment, how to mount it, how to run the software, and the concepts of panoramic acquisition. Thank you for watching.